One of the areas we discuss a lot has to do with using muscle oxygen for doing assessments. And often, like a graded exercise test would be a classical lactate threshold type of test, where you increase the load and then you see where the lactate starts climbing more rapidly with increasing load. People do similar tests with muscle oxygen, graded exercise test, and they look for a muscle oxygen breakpoint. Is that a useful concept?
That is a dangerous question because I'm biased.
Okay.
No, it's an interesting concept, and we started out with that too. And there's no doubt there will be many publications more coming out where people find somehow a very similar type of a trend when you look muscle oxygenation lactate. And depending on the group I put together, if I have a very homogeneous group and I make a very specific protocol design, I may actually find that they're very nicely correlated.
Okay.
The risk is, on the question is, do we create artificially, due to the design of a protocol, a situation where we force your physiological reaction to react the way I like to actually have it reacted? Or do I have to make, let's name it an open protocol where I look when the physiology reacts and not you. I like to show you a simple old example with lactate, which is always discussed. If I make a step test, gradual step test, and I make 2-minute steps, and then I make with the same athletes a 4-minute steps, and I assume it's a similar situation, a similar diet situation, a similar sleep, similar daytime, and whatever we can try to get as close as possible together. I make a 2, 4, 6, and 8-minute step test, and that's done hundreds of times. Even in the early days when Mother was coming out with 4 millimole, you have 4 different lactate curves. Well, first, you have 4 different collections of points where we then try to design somehow a curve in that. And you work with math, you always will find somehow a connection between points. When we did many years back, we tried to figure out whether we can ongoing check lactate by having an inflow and having steady blood. And reality was that there was not a clear reaction, it was just an increase of lactate. And depending on step lengths, the curves were differently.
Okay.
So this is just one example. So now which protocol is the right one? The 2 minutes, 3 minutes, 4 minutes, or 5 minutes? So it depends also in what school you go. You have to say, well, my prof said 3 minutes, and you accept that. Then you go out in the world and use the 3 minutes protocol. Then another guy argues it's 4 minutes.
Okay.
The second thing we see is when we do on the same athlete 3 step tests in a row. So I make now one, and then give you 5 minutes to recover and do another one. We have 3 different curves. And interestingly, it's the last test, which is mostly the one where you're most, let's use the stupid word, fatigued, is actually the one who is most to the right, because you have much less sugar. So you create obviously a little bit less lactate, because that has a connection there too. But you're actually the worst performance. But it looks on the graph like you have the best performance, because we argued that when the curve moves to the right, you have a better performance.
Okay.
And you can go in the literature, so this is not that I try to get rid of lactate, but this is in the literature, and it asks for us the question, how usable is it?
Okay.
So yes, to go back to your question, there is for sure a connection, because both is energy, oxygen is energy, lactate is a part of the energy supply to keep moving. So there is a connection, but there is a lot of, as we said, special situations where we would have to tweak the theory, because the fact we see doesn't work.
Okay.
So to make another simple example, we have a lot of tests where we, in a step test, barely see a drop in SmO2 or in some people use oxyhemoglobin or deoxyhemoglobin, and the people have a very high lactate level. Or I like to explain you one specific situation we often use, because it's really nice to use. We start out and we ask the athlete to find an intensity where he feels most likely comfortable to go for a half hour, very stable. So in cycling, they use sometimes the term FTP, functional threshold power. In the old lactate school, we use the idea, try to find your max lactate steady state. Meaning you have lactate in the system, you can prove it's circulating in the system, but over a certain amount of time, depending what theory you believe, it doesn't change. Well, it goes a little bit up and down due to the measurement mistake of the equipment, but it doesn't change. That's most likely the closest to when we see a stable SmO2 reading in here. So that's why we see there is a connection. If your body is in something called relatively comfortable performance homeostasis, so he can maintain nicely. So it's obviously balance between energy he can deliver and energy he will use. And that's where the max lactate steady state and a stable SmO2 get very close together, hand in hand.
Sure.